Right, so today we're going to start focusing on different types of context problems you can get. We've already started doing this on a smaller scale. Today we're going to look at half, life, and double. We have looked at half and double before, but that has always been each day. Today we're going to change that up. So pause the video and go ahead and do this as a review so that you can understand today's work. If you don't know how to do it, you can pause this video and go to a previous video and see how to do that. So sometimes the question will have periods of time in the question. So let's do example 2 together. As I do example 2, you're going to fill example 2 out, but you are also going to do example 3. All right, so example 2, in a cell culture experiment, 1,800 cells are placed in a container. Under ideal conditions, the number of cells doubles every 5 hours. So going back to our exponential function that we're given in our formula and understanding what each letter means, remember you have A, which is your initial, B is your growth or decay factor, and then X is time. So this is saying I'm going to start with 1,800, so that's my A, and then it's going to double, and so my growth factor, because it's doubling, is 2 every 5 years. So y equals my A, which is 1,800. Then you can do multiply or you can put it in parentheses, both are okay. And then this is supposed to be my time, shift 6 time, right? Now I do want you to get in the habit of, before you just assume this is the answer, I want you to get into the habit of filling out a table and checking to see if whatever you think is the answer matches your table. So let's go ahead and actually do it. So I start off with 1,800 cells. So I'm going to put 1,800 here. Okay. So note the cells are not doubling every hour, but every 5 hours. So when I start with 1,800, it'll double not in hour 1, but in hour 5. So what I'm going to do is, instead of writing 1, 2, 3, 4, 5, 6, 7, 8 like that, I'm going to just do it every 5 hours. So 0 to 5. Then another 5 hours is 10. Another 5 hours is 15. Another 5 hours is 20. And now I know that every 5 hours, I just need to double this number, right? So I'm going to go 1,800, double it, which means times 2. So the next one is going to be 3,600. Then the next time, which is 10 hours, because it's every 5 hours, times 2, it's going to be 7,200. Then the next time, which is another 5 hours later, times 2, it's going to be 14,400. Then again, another 5 hours after that, which will be 20 hours, it's another double. It's going to be 28,800. So at this point, you're going to pause the video and you're going to do it for your question. So read your question and fill out the table. Then unpause the video and we can continue. Right. How many cells will there be after 20 hours? Evaluate the function for when time is 20. So let's go ahead and do that. So 1,800 to shift 6, 20 is that answer there. So let's go ahead and write that down. All right, so I'm just going to round it as well. So I'm going to say 1.9 times 10 to the 9th power. Okay, so this 8 makes that go up by 1. So 1.9 times 10 to the 9th power. So that seems to be a problem, because right now, me doing it by hand, I get 20, our 20 should be 28,800. But when I evaluate what I think it should be for the equation, in other words, this is my start, it's doubling each time, and then X is 20, right? Because it's time. I get a completely different answer, way, way, way bigger answer. So does that match my answer? It does not. Every 5 hours, the cells doubles, not every 1 hour. So time cannot be 20 hours. So let me show you what that means. So if you look at this, what I originally thought it was going to be, and I hit table, you'll see the answer says 0. I start with 1,800. So far, so good. But when I go to hour 1, it's doubling to that 36. But the calculator isn't understanding that I wanted to double what? Every 5 hours, unless I somehow change this function so that the calculator knows, hey, I don't want you to double it every 1 hour. I want you to double it every 5 hours. So think of it this way. How many doubling periods are there? So how can I rewrite time so that it works for what we know? So pause the video, take a second and think about it. What can I do with this X so that it knows that every 5 hours I want it to double, not every 1 hour? I want it to double. Since I'm thinking about it as how many doubling periods are there, if you look at it, this doubles one time here, doubles 2 times at 10 hours, doubles 3 times at 15 hours, double 4 times as 20. What would happen if I change time to 4? 4 periods of doubling. Then I get the answer that I'm looking for. So how can I write this in terms of time? I can say, okay, if I had X, which is my actual time, and then divide it by, I want you to double every 5 hours because I word every per, all right, doubles every 5 and see if that works for every situation. So divide it by 5 so that I can have my periods, and you can see hour 0 is 1800. Hour 1, I don't know what it is, so I'm just going to go to 5. So I'm going to just press enter, 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 enter. 5 is 3600, so that works, and I'm going to keep going enter, enter, enter. 10 is 7200, that works, enter, 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 enter. 15 is 14,400, enter, 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 enter. 20 is, so this matches perfectly. So anytime you're getting, it's not doubling every day or every hour or every week, but it's giving you a period, you then have to calculate, well, how do you split those hours into periods? So basically what you're going to do is your rule is going to be my initial, which is A, my growth or decay factor, which is B, and then on time, we are going to say that I'm going to take my total time, whatever that is, which is usually X, and then divide it by your half-life, your double life, basically how every 5 hours, every 15 hours, every whatever. So let's say divided by half life or half time, I guess. Yeah, let's do that. Let's say divided by half time or slash double time. And the reason I say that is because you're going to get mostly the questions that have these periods are either half or double. So I'm just going to make a general rule like that that should work for any situation you have. So again, your initial is your A, your factor, your growth or decay factor is your B, and then your total time is your X, and then this time divided by the time that is either halving or doubling. All right, so again, pause the video. You're going to come to yours. You should have finished your table. You should have evaluated this function. And now yours is saying something different. So go ahead and read that. But now write out what the function actually is. So my function, which I have not written out, is actually 1800. My start. My growth factor or decay factor is 2. It's growth because it's doubling. And then for time, it's going to be X divided by the half time or the double time. And the double time for me is doubles every 5 hours. So notice it's going to be attached to whatever is going on, right? So it's doubling every 5 hours. That means my time is going to be X divided by 5. That's my general function. It's going to work for anything. So now that I know that, I can go ahead and answer any questions that's asked. How many cells will there be after 13 hours, the nearest whole number? So I don't have to keep pressing enter, enter to find it. I can just type 13. But since I've already pressed enter, enter, enter to find it, this is what it's going to be. And it's rounding to the nearest whole number. So let's talk about the nearest whole number. So you should have a reference sheet that I gave you. So when you're rounding, if you're unsure how to round, we can definitely round it with the calculator. You're going to take the number that you're wanting to round. And after you type round parentheses, you're going to put that as the first number, comma, and then you're going to tell the calculator how do you want it to round. If I want a whole number, that means I want no decimals. So I'm going to say, hey, I don't want any decimals, 0, nothing. And that's going to give me a whole number. If I wanted 1 decimal, you see if I press 1, I would see that. If I wanted 2 decimals, see how I see 2. If I wanted 3 decimals, I would see 3. If I wanted four numbers after the decimals, now for this one, it just so happens that they aren't 4 numbers after the decimal, just 3. So the maximum is 3. So to round to the nearest whole number is 0. Now, you will get some question where it doesn't say round to the nearest. Now, very important, don't write this down. I'm just writing it so that you can see. Let's say we say hundredth with a TH. Okay, that's asking how many decimals after. And because the word 100 has 2 zeros, it's asking for 2 decimals or 2 numbers after the decimal. So boom, like that. Okay, now the difference is that's hundredth, TH, and then there's hundred, ED. All right, nearest 100 is asking for you to take the number. So let's take this number, and it's asking, ignore the decimals, but what is, this is $10,913. What is that nearest $100? $100. So this is 10,000, and then 913 is your 100, right? So 913, is that closest to 900 or to 1,000? And you're going to say it's close to 900. To put it in the calculator, you're going to do it the other way. So hundredth has 2 zeros, so you'd say comma 2 for this one. But because you wanted to look not past the decimal, but to the left of the decimal for 100, ED, you're going to say minus 2. So let me show you what that looks like. So if I say minus 2, you should see it round to $10,900 because $10,913 is close to $900. If I wanted to do it to the thousand, ED, thousand, so I'm looking at 10,900. What is 10,900 close to? It's close to 11,000. So if I do negative 3, because 1,000 has 3 decimals, if I do negative 3 in the calculator, you'll see it do it as 11,000. Okay, so again, very important. If I'm doing ED, I'm going negative. If I'm doing TH, I'm going positive. All right, so back to our question. You don't need to write that down. That's in your reference sheet that I already gave you. But now I'm going to answer my question, which says round to the nearest whole number. So I don't want any decimals or anything, any numbers after the decimal. So that's going to be 10,913. And what is this? Money? What is this we're talking about? Just forgot. How many cells? Okay, so this is the number of cells. So 10,913 cells. Okay. All right, so again, pause the video. You should be able to answer this question right here. All right, the last question. How long in hours will it take for the cell population to grow to more than 50,000? All right, so I'm looking here and I'm looking for 50,000. Right now at 20, I'm at 28,000. So I'm just going to press enter until I get to like 50,000. So boom, this is 43,000. This is just over 50,000. This is 57,000, right? So the question was, how long will it take for the cell population to grow to more than 50,000? So roughly 24, and is this years? What is this? Hours. So 24 hours or 1 day. Okay. So I can say, and it's asking in hours, so I'm going to put it in hours, 24 hours. Now be careful because sometimes the question will change and might ask you in days. If it was days, you would say 1 day, even though it says 24 here, because 24 means hours. All right, so at this point, you should have gone ahead and completed your question. Now let's check your understanding and complete example 4 and example 5. Now that you know the formula, you no longer have to prove it, and there is your official formula. Let's practice.